going over some key homework questions. It did bring up some attention to me when people came in for the tutoring on this particular problem that please, no, make sure that you write that there are two identities you need to memorize. For sure, you know cosine squared plus sine squared is equal to 1. You also know a squared plus b squared is equal to c squared. Just as easily as you remember those, in calculus you have to remember these, okay? Because there's a lot of identity substitutions and whatnot. So the cosine of 2x can be written one of two ways. Sometimes you'll use one or the other. Cosine squared minus sine squared, which is a little bit like this, only different by that negative. But if you wrote it like this, can someone tell me what is cosine squared equivalent to if you're using this equation? Yep, 1 minus sine squared. So if you were to put this where cosine squared is at, the other one that you should memorize, that's cosine of 2x, is that one. And that one's the one that we're going to use today. 1 minus 2 sine squared. Okay, so this other one, sine of 2x, 2 sine cosine. There's no other form of that. So these are identities that we have to have memorized. Otherwise, we're missing things because of pre-cal, not because of calculus. Okay? All right, so looking at this, if I'm trying to find the horizontal tangents when the derivative is equal to 0, and I have this equation here, we immediately go to f prime of x. And I know it's basic, but I will pull it out anyway, the 10, so that the derivative of cosine is negative sine, and I constant multiple roll back that 10 to give me a negative 10 sine of x. And the reason why I get in that habit is because of composition functions like the next one. I'll pull the 5 out. It's a constant. Just move it off to the side. The sine of 2x is a chain rule. What's the sine of 2x's derivative? Cosine of 2x times 2. Don't forget to multiply by the chain. So cosine of 2x times 2, if you bring this 5 back in, it's basically going to make that 2 and 5 become what? 10. So you have 10 cosine of 2x. And right here is that identity that I was talking to you about just now. We're going to substitute 1 minus 2 sine squared. Okay? So my equation then becomes f prime of x is equal to negative 10 sine of x plus 10 distributed across 1 minus 2 sine squared. And I'm slowing down a little bit and showing you step by step so that you can see where all this is coming from. Distributing this 10 will give me plus 10 minus 20 sine squared. Everything else is the same. And yes, we're going to set it equal to 0 because we're looking for when f prime of x is equal to 0, the horizontal tangent. Right now, you should see things that kind of stand out at you. And this almost looks quadratic. I mean, well, yeah, it almost looks quadratic. It almost looks like this form that we learned back in Algebra 2. You have your x squared term, and you have your x term. So if I move it across, because remember that when that a value was negative, or if it was something other than 1, it became difficult, I can add 20 to the left side. I can add the 10 to the left side. And I can subtract that 10 over so that it will still be equal to 0. And all we did was move everything over to the left side. Now, my goal in that was to get this positive. And then now I'm going to do what? GCF. I'm going to GCF out a 10. Okay? So then I'll have left over 2 sine squared plus sine of x minus 1. And then you're just going to factor. Because that GCF 10, if I divide it both sides by 10, it's just going to be 0 still on the right side. And the 10 basically just goes away because it doesn't have a variable attached to it. Okay? So you could just divide that out right now and make it go away. And now just factor what you see left. Okay? So 2 binomials. And the first 2 will multiply to get 2 sine squared. That means one is 2 sine and the other one is sine. The last 2 will multiply to get a negative 1. Now I just got to watch where I put my signs. Because ultimately I want to end up with a positive 1 in the middle. So is it going to be 2x minus 1 or 2x plus 1? 2x minus 1. Good. It will be 2x minus 1, making the other one positive. So that this multiplication will satisfy the negative 1, and that a positive 2 negative 1 will satisfy a positive 1 addition. Okay? So now, set each of these equal to 0. And the first one would be sine of x is equal to a positive 1/2. And the other one is sine of x is equal to a negative 1. When is sine of x? When is the y value? Because it's sine. When will it be a negative 1? At what angle? 3 pi over 2. Now, when will the y value be a positive? There it is. Either first or second one. Pi over 6 and 5 pi over 6. Okay? And all you're going to do with these values is you're going to put them in your position function to find out what is the y value. And I saw some people using the calculator, and they were doing a lot of typing to get those values. Okay? Just a reminder on using the calculator, you can make this a lot easier on yourself simply by storing the function. So real quick, for the sake of instruction, I'm going to show you that real quick with this equation. So my original parent function was, do you have the same numbers I did? No. Was, what was it, 10? Let me just go back. 10 cosine, here we go. 10 cosine of x, and then I'll go back and you can see it, plus 5 sine of 2x, okay? And I'm going to store this as, so control, that's the blue button, variable, and I'm going to store it, let's say, as f of x. So now I could just put, what is f of pi over 6? What is f of 5 pi over 6? And then the last one was, what is f of, what was it, 3 pi over 2? 3 pi over 2. And then you can see which one's the smallest, which one's the largest, and then put them in appropriately. Are we good? And if you don't see which one's small or large from that, guys, you know you can always just go and press Control Enter, and it will change it.
It's based off the x value.
Yeah.
Not literally.
Oh, it's based off the x value? So the smallest or the largest x value? Okay, thank you for that, Luke. All right, questions? Okay, I'll do one, maybe 2 more homework questions that you have. What other questions do you want to look over right now before we start today's lesson? 7? Okay, so 7, let's find the second derivative. We're going to do a lot of that today for sure. So, with implicit differentiation, that is. So the second derivative, okay, so it's all about this 5 to make it a little bit easier. Move the 5 off to the left, just move it out of the way, constant multiple rule. And the derivative of the rest is the product or power rule. 4 something cubed. There's my stuff. Right? There's my filling, if you will, from that Oreo cookie. And we're going to multiply by the derivative of the cream. And I always use parentheses. Even if it's one term, I use parentheses. And then I will multiply that 5 back in via constant multiple rule. We should always simplify our stuff before we derive again. Okay? Because otherwise that's a nightmare to kind of look at. So you see the 5 and 4 will group together to give me what? Like ultimately to give me what? Negative 100, right? So 5 and 5 is 25, and 4 will give me that. This is the derivative. Again, simplify before you move forward. Okay? And now, if I take the derivative, yes, some of you already see it. Some of you won't even move the negative 100 off because of the constant multiple rule. You'll just say negative 300 of the stuff squared. Carbon copy that cream because nothing's happened to it. And multiply by the derivative. And now you see this gave me that positive 1500 and the rest is there. Cool? Again, numbers first, powers, logarithms, all that next, and then trig in alphabetical order last. Alright, one more question. Number 2? Or 12? Okay, so 12. So 12 is looking for r prime. So if we need to know r prime, we need to know what is r of x first. And r of x was given to us as that. So chain rule. We see a composition, so the derivative of the outermost shell is that, with nothing happening to the cream filling. Because all I did was twist the Oreo. But then we got to multiply by the derivative of the chain. That means derive that inside, eat that cream, multiply by g prime of x. So now we're just going to put 1 everywhere where we see an x. So what is g of 1? 4, right? What is f prime of 4? So what's the slope at 4? What do y'all see? So this is f, right? Do y'all agree that that's f? So we're looking for the slope at 4. So it looks like it went 1, 2, 3, 4, 5, up 5 over 1, 2, 3, 4. So up 5 over 4. We still have to multiply by g prime at what? 1? So g prime at 1 is going to be what? What's the derivative on g at 1? 0. So when I multiply it, you get 0. Are we good? Simplify each step as you go, otherwise it becomes a nightmare, okay? Parenthesize whenever you need to. Alright, that's enough of that.